So, ah, good evening, everybody. Thank you so much for coming. You cannot even imagine how I'm excited to have live people here in Chicago Park, because last time, I'm not counting my miserable attempt to resume them a year ago, but last time we all met, it was February 2020, and then there was like nothing pretty much. So yeah. Welcome, welcome, welcome. Several buildings that changed since I'm in charge. So I hope that this is a place I will stick for a while, preferably until retirement, Jared. So you know, just what we discussed. So I hope I will stay here. So it's the same screen we've been seeing for so many years. Chicago Park announcements. So we are starting again our routine. So first thing, yeah, welcome, welcome, welcome. Thank you, thank you, thank you. So that's Wi-Fi. So here is the thing. I did not announce it upfront. So here we are in high security building. So guest Wi-Fi is a little bit different from what we had before. So now I know how to have guest passes. So for the future, if you come and you need like Wi-Fi, just tell me in advance, because I will print the flyers for you. It's like one-time login passwords, and I can generate like 20 of them for each meetup. So this time I just tested it, it worked, but I did not like make an announcement. So for the future, I will note it in our meetups, but there will be just Wi-Fi for everybody who needs it. All right, so next item on our agenda, the conferences from September. So you know that we did not have September meetup because I've been traveling. And I attended 3 conferences. So it was Uptime Conference, All Things Open in Amsterdam, PG Day Austria in Vienna, and then PGConf New York. So that was super exciting. It was super exhausting. I presented on all 3 of the conferences. It's kind of like getting there. So everybody excited. I met like lots of people. And for Uptime and for New York, all talks were recorded. They're just super slow on putting them online. So please keep checking meetup announcements. They will be coming. So Uptime, they like last week they told another couple of weeks. So they're doing like putting captioning. So whenever they will have it, I will let you know, and you will be able to watch their YouTube. There are lots of exciting talks. Actually, like everywhere there are like super high quality talks. So I think that if you'll have time to watch at least some of them, that will be extremely interesting. So that's for September, and next I actually, yeah. So now each day Chicago. Finally, it is official. So PostgreSQL approved, underwrote. So we are having today Chicago, except no like no doubts. So we have a venue, and that will be just one of the conference spaces on Adams, and that will be like one-day conference, April 20th, and the website should go up within a month, I hope so. And we will have like a program committee. So I'm ready to the program committee because of my short-term tenure with ETB. I have lots of connections now, more than before, as if I didn't have enough. I have even more now. So that lots of cool people promise they will come to Chicago to present. So this is going to be great. That's not official. So like sneak peek, that's the upcoming logo for Teacher Day Chicago. So we criticized it fiercely. That's why. Who knows why we criticized it? You know, they like why, okay. Who knows why we did not like this logo? And we send it for like improvement. The skyline is wrong. They cut the yeah, they cut the Sears Tower and the John Hancock. They don't have the spear, so so we send it for them. but that will be how it will approximately look like. So like 2 years ago, when we first discussed it, we said that it should be Chicago skyline should be on this logo. So coming. All right. So another upcoming thing. So next week I will be in Berlin in Future EU. That will be huge. It's a 3 days conference plus 1 day training. So it's like full week. And each week of the conference, they have 4 tracks. And all tracks are so interesting. Honestly, I want to be in all of them. But I do not know what I will be doing because the talks are amazing. So again, I think that they will be recording and I hope that they will be online. I do not know when. Whenever I will know, I will let everybody know. That looks fabulous. Actually, Robert Haas will be talking. You know how often he talks? Like once in 10 years, he'll be talking. So, I'm super excited about it. All right. So, what next? Yeah, so pretty much that's all my like 5-minute intro. So now, you know, if anybody did not come yet, it's like their problem. And yep, let's proceed with this one. So actually, no, hold on. I ended too early. Yes, I ended it too early. I forgot to make an announcement about what was there and what will be coming. Sorry about that. Let me actually continue. Sorry. Okay. So one more thing. So we will have meetup in November, and there will be Aerospike, and so they will be presenting their thing, and there will be no meetup in December. And those are all our talks for this year. So we missed August because we always missed August. We missed September because I was at the conferences, and I'm talking today, and there will be Aerospike in November, and we won't have December. So that's me. And this will be 2-dimensional time or changelog. So what is with this talk? That is the talk which I will be presenting in Berlin, and which I'm kind of accidentally presenting in Helsinki. So, okay. Play from the start. Okay, hopefully everybody sees it. Yeah. So, you know, like in April, I like told the head of the Helsinki Postgres group, if you want me to present, just check when I'm in Helsinki. And they reached out and said, when are you in Helsinki next time? And I said, I have 1 day before Berlin. I said, can you do this? And they already sold out. So, by the way, what I want to tell you guys, I had like 20 RSVPs here. Not a lot. Helsinki already has like sold out. They have 40 RSVPs and 14 waiting lists. So I think it's covered. So that is my like dry run of the stock. And okay, time travel, yes, but how? And okay, who in this room heard my previous bitemporal talks? Any of them? Any of them? Just did it. Come on, you did. Okay, 1, 2. Okay, 1, 2. Okay. So some people heard these talks like 20 times because I've been presenting them everywhere, trying to like kind of attract people's attention. Intermediate success. But now I had at least like one good reason to resurrect this topic, and I was very happy that they chose this topic for future conference. So the official name for this talk is changelog or 2-dimensional time, which one works better. And I will have to move very relatively fast through my model because I need to show something else in addition to my model. Because the purpose of this talk shows why my model is the best. Except for it's my model, but my model should be the best, but I actually need to show why it's so. So if there will be something that will be like totally like I'm moving too fast, please stop me, interrupt me.
will try to fit it. Again, my goal is that for those people who need to leave earlier, they will get most out of this presentation. So I'm trying to be fast, but not to the extent that like, nobody understands anything. So, why we are speaking? So that's a big reason why I'm speaking about two-dimensional time again. I am doing this for almost 10 years now, I want to say, like at least 9 years. And I presented million times, and I almost gave up on this topic. But then what happened? Postgres Vision Conference 2020 happened. It's a huge online Postgres conference powered by EDB. And I didn't even listen to the keynotes because I was working in EDB and I was online, and I had a client. And then people started to slap me. Hey, Katie, did they talk to you? I'm like, what can I talk to you about? So that's what happened. There was Mike Stonebreaker's keynote. Okay. And Mike Stonebreaker identified 4 things which he wants to see in Postgres. And first thing was time travel. So like he said that that is something which is overdue, have to be implemented in Postgres. So that's why people started messaging. Did they talk to you? No. But I'm excited. And then there will be a couple of slides from his presentation, which I saw. So that's what he wanted. So he said he wants to be able to select from table at some certain point of time. And what he said here, this at certain point of time does not mean that we have multiple copies from the table. It's one table, but it has all this history. And also, that's what he said, that his original implementation was bad and he had no issues with the fact that it was removed from Postgres very early times. But he's saying that it's overdue, and I completely agree with you. So why I completely agree? Because Postgres is the best database to implement time travel. And I was heavily relying on Postgres features. So now that I am in TRW, and we actually have a need in data warehouses, which are time-driven, I'm just telling you, Postgres is the best solution to support time. So let's see. How about it? How time travel is catchy phrase, but it's all catchy phrases. What we mean by time travel, what we mean by supporting time. And here comes interesting thing when we start to talk about it, because everybody wants to be able to do point-in-time recovery. Not of the whole database, as we have like ways of doing it in Postgres, but like this particular table, this particular thing, because oh my gosh, we messed up because okay. Jerry can attest, like disasters happen not because data centers burned down. Disaster happened when somebody deleted table without conditions. So, and then like
common.
So everybody wants to have point-in-time recovery. No problem. You come to your manager, say we need point-in-time recovery. Yes, we need to have this. Changelog. Everybody wants changelog. Nobody has issues because if somebody went to the database and changed something, we want to have this audit trail. We want to see who changed it, when changed it, and how they changed it. So you say, okay, I want to implement changelog and triggers, and people say, yeah, yes, please. And then comes Katie and says, two-dimensional time, bitemporal table. Like, what? Why we need bitemporal? And bitemporal is complicated. And if you keep everything in the database, it's too much space, and it's very convoluted, and it won't be efficient. It takes a long time to query. So no. So let's talk about bitemporal model. Again, I think there are like only 2 people kind of admitted they heard it, so we can talk a little bit in more detail about bitemporal model. So quick refresher for those who already know it, and like explanation for people who see it for the first time. So bitemporal functions are obviously operating on bitemporal table. So if it's bitemporal, it means it has two times. One time is effective time, that is what you expect. Effective when this situation that took place, when these values were affected. And then asserted time is the second time. And that is not system time. It's not the time when you put changes in the database. If you want this time, you need to have third dimension. But asserted time is kind of like the time when we believe that was true. So like like not necessarily for the right away. We
Wait, hold on. What is? Am I not muting people and there? Okay, hold on. I'm not sure. Okay. Okay, folks, who is on Zoom, can you please mute yourself? Because now I'm in the middle and I cannot really mute you.
all right. So, like good example, what is asserted time? You know, this whole model started from the imaginary concept of manless data center. If you need to switch all your IP addresses at midnight, December 31st, you do not need to be physically there. You do not even need to be by computer. You can say you asserted starting from 0 o'clock of January 1st, and then it becomes visible. So you make this change when it becomes visible at a certain time. And I will go through a couple of examples where I will explain what exactly it means. So one important thing about these two times, it's not a SQL standard. So the concept of temporal tables were introduced in SQL in 2011, that's NC standard, and DB2 and I think actually Microsoft SQL Server as well, and Oracle, they implemented something which is close to standard. So that is not standard. That is a asserted versioning model developed by Johnson and Weiss like long time ago, super theoretical. So they didn't know how to implement it, and it happened to work perfectly in Postgres. So now it will be kind of like mixture between the theoretical operations and Postgres implementation, because I mean I implemented them in Postgres, so it will be a little bit intertwined. So what we need to operate in bitemporal tables, we need to be able to create them. We need to be able to insert in the bitemporal tables. Then we need to be able to update. In the two-dimensional table, there are two updates: bitemporal update and bitemporal correction. And there are also two deletes: inactivate and bitemporal delete. And if you can imagine, nothing disappears. Even if we're saying like it's bitemporal delete, data is still in the database, just made invisible. So that is how we create. And again, here I'm just showing the function which is in my GitHub. I will show GitHub in a second. So we create bitemporal table. We pass the schema name, the table name, and then next string, we pass the TDL for this table if as if we would create like normal create table. And the last parameter is the business key, because in our temporal table we have multiple records for each key. So it's not primary key, but it's still like primary key for the outer world. So that's we call it business key. And then if you look at after you ran this create table, if you look into Postgres database, and what in the world we did, we created this table. So you can see there are lots of things which we didn't say anything, they were created. So what we created here, this like surrogate, actual surrogate key, then this row created again is internal, and then we have these two time intervals, and then we have this keys with exclusion, and that's what drives that bitemporal implementation in Postgres. So now I will come back to this. So that is our important part. That makes bitemporal implementation in Postgres. That's why they did everything for us. So why Postgres is the best for bitemporal? First, because we have interval tags. and we have them for a while. So it's not beginning of interval, end of interval, like one interval is like one field, one value, one variable. So that is huge because you actually can operate with effective and asserted as intervals. Second is plus minus infinity. So what is infinity? Infinity can be number and it can be time. So it means that that is the value which is greater or less, if it's minus infinity, than any other value. So if you have any date in the past, in the present, in the future, any date will be always less than infinity. So if you want to represent the time interval, which is true now, we are saying it ends in infinity. And this makes lots of queries much easier because we do not need to consider separately or if and is now. Because, you know, any date fits in the current interval. So again, lots of problems are gone. And then gist indexes, so there are special like spatial indices in Postgres, and the ability to create gist with exclusion. So that's what we created here. So what this condition says, it says that for any business key, these intervals, effective and assertive, will never intersect. So basically, we guarantee that this value is like always in certain moment of time. If you think about effective and assertive as like X and Y, there'll be always one tag on this rectangle. And that basically like that, you know, we don't have to do anything else. It's there. It's important. Now let's see where we are. So I will try not to spend the rest of the time on this, but if something is completely out of line, please stop me. Okay. So how we are doing bitemporal inserts, and you know, my very generous developers looked at this presentation earlier today. They kind of like, it's a little bit outdated about 2015, and I do not want to be that because that's what he does. He doesn't update his presentation. But actually, no, it's like making the slides is super difficult. So I will try to update them, but not like in the next 2 weeks. So let's, unfortunately, let's travel back to when I started this work. So 2015. So that's a very simple example of how bitemporal tables work. So say today is May 1st, 2015. So we are bitemporally inserting one row in the table. So what we're inserting? That's the customer number, that's his name, that's their silver, and we're doing effective from June 1st, asserted May 1st. So what it means? It means that today is May 1st, and we're telling that they are becoming our customer starting from June 1st. So we know it now, but we know that they will only become customers on June 1st. And if you look below, so that is like kind of the time region. So there was nothing. Now we have like started, effective, start, effective. So that's one insert so far it's understandable. Now, here comes my temporal update. And now things become more interesting because not only we updated, but we updated like only the time interval. And all of a sudden we have 3 records instead of 1. So why 3? Why not 1 and why not 2? So let's see what we do. So first of all, we're saying our previous record, when we're saying they are silver forever, is not true anymore. We asserted it from May 1st to September 15th. So today is September 15th. Now, what we assert now? Now we assert that they were silver from June 1st to September 15th, and we asserted now in they were silver, and from today day until infinity, now we assert that they are gold. So we have like 3 rectangles now. So if we go back in history to any date before September 15th, we see only 1 record in history. If we look at it now, then we will see the like first historical record, which ended on September 15th, and then the next one pointing. So that is a bitemporal update, and you can see that so That's what we updated this one and we inserted this two. Okay? So now, how correction is this? This is the best part of that. So why we need seven? So a week passed, like we made mistake. Actually, we updated it wrongly because they were not supposed to be updated to gold. They were supposed to be updated for platinum, and they never were supposed to be gold. That was like honest mistake. So now we're doing bitemporal correction. What was it? We're saying, okay, so that was our old record. Scratch it, meaning like close assertive interval. Today is September 22nd, so now we realize we made mistake. So we close assertive interval. Now we're adding the correct record. So from September 15, today's 22nd, but we know it should be from September 15. So since today's date, we assert that they are pledged. So what will happen now? If we query this table as of, say, like September 1st, we will have only the first row. If we query it as of now, we will have two rows, which will be like row number 2 and row number 4. But if we go like any day of this week from September 15 to 22nd, that's it, and if we run report at that time, then we will see two different historical records. So that was when we made mistake. Because you know what our accounting department likes? Accounting department, why this report was different? I rerun it now it is differently. Can we rerun it as of the end of Q3 last year? No, I cannot. Unless I have this. Because now, if they made any mistakes, if like some transactions was like rolled back at any point, I can run as it was now, and I can tell exactly why it was looking differently then and it looks different now. So that's bitemporal time. And then like so really quick to like deletes. So inactivate tells us like okay, this person is no longer effective, but to have their history. So now I say today is November 5th, and we know that they will stop being our customer on December 31st. So that's how it looks. So now the effective interval will change from September 15 to infinity to September 15 to December 31st. But assertive interval will remain the same. So if we query the history now, we can tell that they will be inactive, but we can still see them as like not our customer anymore. And if you come next day and say, you know what, scratch it, we do not want to see them. Then we do bitemporal delete. So when we do bitemporal delete, we end both effective and assertive interval. And now, if we run the report as of now, we do not see it. But if we run this report for the like previous day between this, we can see all this history. So we can make it look like they never existed with delete. But we can run any reports, any queries in the past and see is it that. So that is like in a nutshell how it all works. And granted, the real life is way more complicated because in real life we do not update individual rows. We like update this select, like correct the select, insert the select, and we do bulk operations. There are lots of things which can be done. But that's like pretty much like the gist of it. So any questions about this? Okay, we can talk after. Because it's all like running and working and okay, so you can take it once and get this code because that is my GitHub. So for those who remember the old times, so the first version, and if you see my older presentations, now it's like many conferences before, the GitHub was from Scale Genius. So I worked from Scale Genius because like unfortunately our partnership with this organization is not in effect anymore. So all the last bugs are only fixed in my work. So if you want to see like the latest and the greatest, go to my form because until like last year, until November last year, these two forms are synced, but now the latest is mine. So now, as I said, I gave this presentation for many years, pretty much the same. You know what was the reaction? Cake is super cool, but it's super complicated. So nobody will ever do this. I still remember how long it took me to explain to Bruce Mountain how it works. Like 2 hours, okay? And okay, actually in Helsinki to the Regatta Cafe with lots of hot chocolate and cinnamon buns. Okay, but yeah, we got close in 2 hours. And then he said, cake is super cool, but we do not have customers who need it. Like, what are you talking about? Everybody needs it. They do not know it exists. Anyway, so that's what I was getting. And then on one of the meetups, when I was talking about this, meetups, so somebody actually put the request and put an issue in GitHub. Can you write a tutorial and example how it works? And like, okay, give me an idea, I will click. If they gave me an idea with like classical examples of customers, like staff, orders, order lines, and I built this example, I did this tutorial, I read it several times, like everybody happy, everything was cool. So then this kind of toy tutorial, first of all, there's like 2 lines of like, okay, what you can demonstrate except of it works. And the other thing is, after my Stonebreaker said we need it, people started to theorize how we do this. I know how to be done, who listens to me, very quickly, right? People started to theorize how it should be done. First of all, they said, yeah, there should be separate tables of current because we need current like almost all the time. Like, who told you this? We will work efficiently without separating the current, having the current is after like nobody else. Then what is better to report changes before go or just to individual attributes? Maybe for individual attributes, it's better because they're small. They never try. They do not know how to in real life. So I kind of like tired of it, but also I wanted to build real life example. And again, who here remembers about PostgreSQL database? Nobody, one person. PostgreSQL. Jay, do not tell me you don't remember about PostgreSQL. I will be really upset if you don't remember about PostgreSQL. Yes, okay, it is one person. It is one person remember. So PostgreSQL, that is the largest publicly available Postgres database. It's like really gigantic. And we created it when we worked on Postgres query optimization book. And that's my big contribution to Postgres community. So anybody can download it and like play with it and follow examples from the book. And then okay, so I created it for people by icon. So what I did, I went to my database and I pulled the data from there and I built a temporal example based on my own data. While I was building, we encountered so many issues with current Postgres there. So I need to go back and fix it because there are lots of things like people were flying like too often or like, things like this. So there are lots of things that we'll need to clean up. But this example is kind of free. It's not in GitHub. So if there will be public demand, I will put this work in GitHub stuff. But now I will just show the example just for the context. It's built from PostgreSQL. So if you like look, so I mean, my GitHub is relatively small. There are like 4 projects, and all of them are kind of intertwined because all of them about the same things: how to work with application, how to work with time, and all this training. So that's okay. We created the database in the midst of COVID. So we started working on this in spring 2020 when we could not fly, and we were kind of like, it was imaginary, our dream database. So how would we fly if all the world would be ours? So that's why we chose it, and we recently upgraded it, moved it from 2020 to 2022. And we canceled all flights to Russia. So now, like, we work on the database, doesn't fly to Russia anymore. Postgres Pro air database, they actually have all flights inside Russia, and it's very appropriate let them run. So anyway, in this database, we had we have a frequent flyer table, which is static. So as any loyalty program, you have frequent flyer ID, you have that personal information, then you have your level, like, gold, silver, gold, platinum, and you have all these like award miles, status miles, and how you use it, how you earn them, how you spend them on flights, etc. All these things. So in PostgreSQL, it was static. And really side is like the best example to show dynamic, because in reality, you book the flight, you might spend, or might not, you fly, you earn, then your upgrade can come, you earn enough miles, so that's very good dynamic. So our bitemporal table, what it has? So transaction fee, that's like again internal, frequent flyer ID, that's our business team, and then a level of loyalty, booking leg ID, that's the last booking which was made, and current event points, and status points, and effective asserted and raw credit. So I built. Actually, I actually went through the flights and I built it for each of the frequent flights. So it actually reflects what is important to say. And what is the good one? Now you can query it, and you actually can query. So that is you can put how many rows. So I did not put. Yeah. So this table is 4.5 million rows. So this is a big thing. And the only index I purposely did not put any other indexes except for this gist with exclusion, which is like required. So everything that I'm showing is executed like under 100 milliseconds. So you can select current situation. So this SQL will show you what is the current status of all frequent flags. So that will be something like that. So like, we have this frequent flyer, we have their levels, and we have event points, status points, and effective asset. So that's like everything what is current. Then what we do here, we want to show the same thing as your loyalty program shows you when you log in. So like I log to Finnair and I see all my flights, and when I spend points, when I earn points. So we are selecting the flights with specific frequent flyer ID. And look what I'm doing here. I'm building the history and lower effective is the start time. So effective is the interval. So this is the beginning of the interval. So it is time of change. So I run this SQL. And that's what I'm doing. So what I have here, not the identity result. So that's 14 flights for this frequent flyer. So here I'm showing what was departure airport, arrival airports. I'm saying how many what points and status points they have at this moment, and when they use points, when they earn points, and that's when they change levels. And then the status points were like reduced, and all the other stuff. So basically, what we see when we go on to your work program. Now, okay, that's also good, but you know what? How about the change? So we still want to make sure that you can do change logs and we do the need to store change logs setup. Because I mean, it's true that quite often we need to see the change of one specific entity. And I show history of everything, right? So how to build change logs. And is another great feature of Postgres, which they know window functions. So window functions, you know, I always tell people when they use window functions inappropriately. Inappropriately, like, you know, instead of select max, they're like ranking and then selecting first. So there are many ways to use window functions improperly, but there is one problem. When you build this selection and you build the history based on window functions. So here we go. I know it's small, and I will put this presentation to the meetup page so you will be able to see. But let's try to see what we're doing here. So I am building this from the bitemporal table. So my window is by frequent flyer ID. And within frequent flyer ID, I order by row effective, which means I'm building history for each frequent flyer. And it's always what we see now, so current history. And now I'm building this for what points. So after I build this one, I am selecting from this grid only the lines where balance change is not there. So now all the changes which I'm selecting are changes for what points. For the others, I have again, this is executed again by under 100 milliseconds for everyone. No, that we do not need to store. So the point is we do not need to store and we can always be the modifier. So if you want to select more details, you can join same story. You can join with the booking and the airport, and then it will be like all histories again how we see in like your world program. So here we have like time of change, and we see what's the flight, and also we see, so here we see that we use the points, right? So we see points used, because so that means that we book this flight with points, and we book this flight with points. In this flight, we earned points, so we flew it and we earned, and here we use the gain, etc. So all this, we can see the history and we can see what's happened in the history. So moving and this one, same story, just for individual frequent flyer, one person, and same thing with, we can see how point balance changes. Which flight, date, and whether points were used for flight. And we can do it for any, so again, we do not have to store them for any of the attributes which is changing. We can build them on the fly. It's like so fast, it's not even fine. We didn't need to store. No. Now, so we can do everything with bitemporal model. So now, let's give a benefit of the doubt. Say we, instead of bitemporal, we will do changelogs. So we have 3 attributes: pivot points, status points, and level. And now we need to do the changelog solution. So I build the tables as if it was that changelog. So I have 3 tables, like pivot points changelog, status points changelog, and level changelog. So first thing I can tell that they are actually like the, oh, you know what, I did not tell like so the total is kind of like more than any of these current points, and the total size of these tables is more actually than bitemporal table, because also you need to have the current table separately, and I didn't put all this arithmetic here. I will put it on the next presentation. Now, what we are doing with this change log. Okay, so if you want to actually display change log, it's easy because we are storing them. So the only thing you need to do, you need to like go for this and do it. So now, oops, okay, where I am. Yeah, right. Right. Okay. So now, what if now we want to do the opposite thing? The opposite thing, we want to reconstruct like bitemporal. So say we do not want change logs. Now we want to see a history at given point of time. So what Mr. Stormbreaker wants to us from us, he wants us to be able to query a table at any point of time. So now you cannot actually query a table at any point of time. You can construct as if you are querying this table at any point of time. So you need, for each of these change logs, you need to find the place what it looked like at this specified date. So here I'm doing this for July 1st. So I am building all this CTE to find what was the about points balance on this day. So you basically replicate this like time interval. Then after this, you do the same for status points, another CT, and after this, you do the same for the level. So you build 3 CT for this specific thing. If you do not tap it in here, it will be more horrific, but let's do it in the most efficient way. So we need to tag this thing 3 times. Now, and then you write this query where you use all of these CTEs, plus you also have to join it with current status and do all these calculations. You know why you need to do it with current, because if this record didn't change, then it's never interchangeable. So imagine there are like people who never change the status. Status is like the smallest change of table. So if status did not change, there is nothing interchangeable. So you always need to go and check maybe this value is current. So pretty like horrific thing. I mean, and that's optimally built. Like let me tell you, we like experimented with different ways. So that's optimally built, and yeah, it works. I mean, it works, but it's like how I should put it, counterintuitive a little bit, right? So creating the like status either current or at any point of time, it's way more complicated. But it works. That's how it looks like. So that's the result of this previous select. Now, if we want to try to do this in kind of like generic way, because if I want to satisfy my Stonebreaker's wish and like query whatever at given point of time, then we need to build generic like join and then query at point of time. So that will be interesting. So how exactly it will look like? So first you will need to build like 2 CTs for each of them, because first you build this historical CT, then you need to unionize it with like 1 extra for current. Then you do the same for each of them. Then you build this CT, when you join all of them, do this all coalesce. I will just tell you from details. Again, I will upload presentation, you can look it up, and then at the end you can do it. So this okay, it's let me say it's like at least 20 times more. So again, doable, but not fun. Okay. So conclusion. What is better with bitemporal model in comparison with Changelog? So it's less crazy. Definitely. That's like, I don't know why people think it's more, it's less crazy. Then easy querying at point in time. So querying point in time is natural, because nothing executes like on a fly, and it's very natural to write queries like this. So basically you need to put this filter for which point of time you want, and you have it, and if you can join several bitemporal tables, so simply you put the filter point of time and you have it at no cost, right? Then building individual changelogs, that is like super easy. Again, you use window functions, you go one way. So beauty of window functions, you do not need to query table multiple times. You order it, go once, and you build, and it's there. No problem. So it's any number of them. And by the way, you know, the more attributes you want to track, the more tables you need, the more space it takes. Then all this cost of building correlated queries. So one of the things that we want from time travel, we want to be able to query as over the time when this event occurs. So this like time correlated queries. So this is also like when you have bitemporal model like this, no problem. With changelog, so changelog implies that you have current status and everything else you need to pull in and kind of like roll it, reapply it, make sure you are in the correct point of time. So that is like way easier. And one extra bonus, so changelogs do not support correction. I mean, when you do changelogs, you cannot tell whether it was a mistake we corrected or it was like a valid change. There's no way to report. So you either skip corrections or you just treat them same as part of history, which is neither of them. So yeah, that is in a nutshell everything what we have and everything what I'm going to present in Berlin. And once again, there's my GitHub. Please give it a try, use it. It does not bite. It's not scary. I know it looks scary, but it doesn't. So I have like, I'm not saying I have many, but in addition to Brilliant, like 2 startups who started using it, and they started to give me like opening issues, and I was like, oh my gosh, I never thought you can use it this way, or should order. So I fixed so many bugs, and other people, not me, start to use it. So I am very, very happy when people use it, people try it, because everybody who starts to find bugs and I fix it, it becomes better and better. So in terms of like response time, I optimized it to like insane degree. So the only next step is if somebody will actually make extension of it, if they will rewrite it in C, hopefully it will be faster, but with SQL, it's optimized to like maximum possible. And what else? So through this past several months, I had lots of conversations who want to take it. So like semi-official statement. When I was with the DB, I talked multiple times. And last time I talked with the Bright and of course in May, he said like, come to me in a month. I came in a month. They said maybe for the enterprise edition server. And there's one more company who is going to work on it for the community edition, but again, they're going to work on it. They did not start working on it. So that is open source 100% up for grab. If anybody is ambitious enough to try to make an extension, please, because I'm not a programmer. It's been a while since I programmed in C. Not like I never did it. I did it, but not currently. So that's all I wanted to say. I expect lots of traffic in this report after today. And yeah, so that's it. And we actually are like 5 minutes to 7 when I was hoping to finish it. And questions, critiques, and helpful suggestions, because this will run next Monday and this will run next Sunday. So there are 2 official runs for this. Okay. Like, what how long will take? To build the data of what? Yeah. To build, how long it took me to build it?
Yeah.
10 times longer than expected. No, that was insane, because honestly, I thought it will be like this, and I totally underestimated how long it will take. So my coworkers who are here, they thought like for several weeks, I was like, I am working on this for the whole weekend. I had no idea how long this example will take. It was huge. So I might actually outsource it, because I didn't want anybody to struggle with this. That was insane, because I thought I would just take it from the database and build it. And then I found, okay, so there are duplicates, there are like, you know, one person is on 2 flights and things like this. So we were like sanitizing. So fortunately, you know, my husband helped me a lot with this. I'm like, okay. So that was insane. It took forever. So I'm very happy that I built it, because now it's a legit example, and I'm like super happy that I have, because now I can show lots of cool things. Yep.
Which one is better?
Which one was it?
Changelog or
I always knew that bitemporal model is better. So now my hope is that other people will deliver. Because I actually, like as I said, you know, I always love when people take this, like accept this talk, because when I submit two talks, and one of them is bitemporal, it's never got accepted. So I kind of used to this situation, and there were like two occurrences when it was not the case. So Simon Rich accepted to propose this London, and I think totally out of deal because he promised me to put it on Postgres 11, 12, 13, and then like I gave up and stopped bugging him. So I think out of guilt, he like accepted me for Postgres London, and I was very happy to talk about this. And why they accepted it for PG configure, I don't know. They accepted, and I'm super excited that they accepted it. So yeah, I hope that it will bring the point across, especially after like Stormbreaker tutorial. That's my big hope.
Did you ever solve so the foreign key aspect gets
Oh,
messy if
yes,
your
I
convention tables
solved it. I
are,
solved it. Yeah,
Oh,
yeah. Yeah.
because for fact tables, it's not that much of a problem, right? You add a new row and it's got a foreign key pointing outward
Now,
to.
I can do dimension, so dimension by temporal and text by temporal, I can do it.
Because that was everyone's complaint.
I know.
So this is
You know what?
really cool, but what happens when there's foreign keys?
I have it, and I will tell you how actually. It's very
Tell.
because I was like, when I started building it, like not this example, but in general, by temporal, I think I spent like several months trying to think how you can do it. Because technically speaking, they should be bitemporally dependent, and that's a fact, right? It's very slow. You know what I realized that? Again, bitemporal, things do not disappear. So if you have this key, it will always be the same. So if you check on insert, so how the normal foreign keys are like implemented. We have this internal trigger, right? Just like R underscore trigger. Okay? They go to the parent table and they check that this key exists in the parent table. And so here's the thing. I do not need to check anything on update because new records are only insert. So when I update, I only update the time interval. And I know that when it was inserted, it was there. So like the only thing I need to do, I need to put additional trigger on insert where I check that this key is effective at the moment when it was inserted. Because then when I end date, I do not change it. And when you do update, you again check at this very moment that this foreign key exists at this very moment. Period. You know, I didn't realize it would be so simple, but I was like so happy when so in this PG bitemporal, what you can see, there is like an example how to build these triggers to add foreign constraints. So the only problem I have, they won't be displayed correctly, like when you do like /d. So what you can do, you can display constraints which describe it, how they look like.
Yeah, so you have your own, you've defined your own functions to do that, but you've registered them as constraint triggers in Postgres, right?
Yeah, I mean, it's not constraint triggers because I cannot. I'm not an extension. I'm Katie. Okay, I'm not an extension. So I just implemented. So when you implement your bitemporal system, you need, whenever you want to define bitemporal foreign key constraint, you need to create a trigger for this attribute. So for example, okay, like your realm, okay, loads, right? So you want to have like account ID, you want to have foreign key account ID for load. So you create trigger to check whether this account exists in the account table. And then it's a trigger function. And then we put trigger in any of the bitemporal table, which want to reference this account. And the only thing this trigger does, it checks whether parent exists at this point of time. When you insert.
Yeah.
It ended up being way easier than I thought. Yeah. Like it took me a while to process.
Yeah, there's a way to define regular triggers as constraint triggers without doing anything fancy, then you can have deferred firing and all that good stuff.
No,
Also, when you first came up with this in 2015, that was before the range data type. Does that,
No, they actually, they just appeared.
was it just at about that time?
Yeah.
Does that fit very well into this
No.
with the timestamp and the interval or?
No, the original model by Johnson and Weiss, they did not have intervals because they were theoretics. So they had start and end, and that was like, and for the end, they choose some date like, year 2000, whatever. So I actually realized that I can implement their model with intervals and will be easy. And then this came out, this I could not believe that all my work problems are solved. When I first created this constraint, I like, let me try to pull it, let me try to pull it, let me try to see like, so that's like honestly, Postgres is the best to do this. No other database has all this stuff.
If I understand this model correctly, your largest tables with the most data would just be in the node, because you never actually have to like delete it and take in terms of like what secret information is right.
No, I mean, okay, it doesn't matter like a small, so this is this example. So I can tell you that in real life, so this work is very unfolding that I'm so speaking so confidently. So I built it for 5 years with Raven Holdings, and we had both OLTP and the lab. So it was not only that the warehouse, but our applications were running on bitemporal model. So, runs sort of thing. In Amazon RDS, I started from like development size instance, so like we did have any performance problem. Again, so the only thing which is updatable are time intervals. So basically, when the record is inserted, for this record, no attribute will be updated except for when we do bitemporal update, we update effective and asserted interval. So all other are inserted. So new value is inserted. And if you look at this how it is done, you'll see I actually kind of like select all the records which satisfy this criteria, like save their surrogate keys, and then I insert them twice, and then I insert that update the new values, and then I put all this time interval from. That's how it works.
Yeah, the reason why I was asking is not working. Vacuum responsive. So that's kind of what I was wondering.
Welcoming was fine, actually, so the older situation when we had problems with welcoming, we had once a day, like gigantic sync with external growth, and then we had like 100,000 like updates at the same time. So then we had to sometimes file like a separate route. But again, that was honestly it was Amazon RDS like kind of not really optimized, like whatever the kind that was and by the time I left, I think the tables like not the biggest but most active tables were like 6 to 700 million records. No partition and no hidden partition, just like a chunk. And what was good in this application, they had like timeout in the application for 10 seconds, so that like no way, no accidental. They did not want it to time out, so if something to start becoming slower, like I need to run it. This is why I optimized it to this insane degree, because that's very fun. It was very happy. Any more questions?
So if you had to have large payloads on any of those rows, you would put them in an external table and just refer to them, and that reference would not, the reference would be, of course, duplicated as the rows were inserted, but they would just be a key into the other table storing the big payload. So you didn't have to duplicate all of that each time you do.
So it's set again. So when I'm loading that to data, my flow.
Right, because you're not actually deleting rows,
Yeah.
the table will theoretically grow, of
Yeah,
course,
no, it goes, yeah.
rather than a regular table.
Yeah.
If those rows had a large payload of some kind, like text field,
Yes.
you would want to store that in an external
You know
table.
what,
just
I
refer to it.
probably would, I never had this situation. But I mean, so the only time when we had to store documents were in external tables by default, and there was like the documents were stored like files.
Right.
Like logs, can be stored separately, they can be stored credits, they can be stored like on the S3, they can be stored whenever. And yes, for this one, we would just have a pointer to where they're stored. you know, again, the Brave Act is the same, it says in Nova, so it's like loans, loan agreement, and like blah, 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 all this like, whole bunch of documents. So you have documents, and documents are like updatable, and then you have links to the actual documents which are stored like somewhere.
Right, sure.
And what else? What was from So we loaded, you know, the credit agency's files, and it also, so they're a mess. For this one load, like, I don't know, like, the lots, like, it's about million over the same time, yeah.
So XML credit reports or something.
XML, okay, the one thing I'm not doing, I'm not parsing XML report, XML that somebody else parse XML.
I think that's how we're still getting our credit reports, but they're,
No, I mean, XML, I will definitely parse outside, but then you can do all the results. And then we have like, how this goes, like, you know, direct mail, like household, direct mail, from great pensions. So, I mean, I actually did it in this report. I'm not saying it will be responsible. Sky is the limit, but. So this was on the cloud, in Amazon. So I think in-house it should be even better. But no, it was on cloud and not even in EC2, but it was on Atlas. I'm sorry, but without traditional storage, and I don't know how I actually was brave enough to run it without traditional storage, but that is go fine.
you know that when I first looked at Postgres, it was in about 1995 or 96, when I went from Postgres 95 to Postgres.
Yeah.
And I remember the time travel support.
Yes.
I don't know, because that's going back like almost 30 years.
Yes.
I don't remember if I ever tried to play with it.
No, Stonebreaker
I'm
said
sure
it was lousy, he removed it. No, that's what he said.
Well, in Postgres, doing that in the back end would involve like not ever being able to vacuum away old rows and then keeping timestamps correlated with transaction IDs and being able to change the visibility aspects. So I can imagine how it can be done, but nowadays we have the so-called heap-only tuples, which means that multiple updates on the same row don't necessarily create more rows in the heap. They may reuse the one that it's actually storing.
Surprisingly, these indices are referenced perfectly. And when I was not sure, I spoke to Nasty in one of the conferences. I like, okay, you're the expert in document, like tell me. And she's like, I don't know, hey, you need to try. I'm like, okay, I will try. And I actually compared the both, and they are referenced like better than this. I was shocked. I was ready for all sorts of like, oh, what will happen, because you know that was new for me. I did it like first time, it's like new experience. So I was also like, oh my God, what if I will find out they are not actually wrong? So, I do not know why nobody knows what Vacuum does within the system.
So you can estimate, is there any drawbacks that why would you use it?
Okay, I think like most important drawback that it looks ugly. Like honestly, because you know if people want to use this function, so you imagine you have application, and your application does like insert like whatever, all that a bit for RAM, and then that what they're doing to this is for RAM. So that is my struggle, because I need to teach application developers to use functions instead of whatever their ORM is sharing. So that's a separate struggle, but it's like my other big topic about norm and stuff. So that's mine. So the other thing I actually partitioning is different here, because like there are some though partitioning in Postgres, you know, there are many cases that we do not need to do partitioning except for if we need like to. So the all the reason is when we need to throw partitions at some point, we do not want the table to be like 100 terabytes like one table. So we need to plan for throwing like in the future. The only way you can actually partition this tables is by the survey, which is actually good, And that is something I did not do it like automatically because I did not think about it until recently. But I might add this like semi-automatic support package. So because otherwise, you know, if you partition the partition automatically, it just will not go right because you went up. Because on the outer world, you do not see what you exactly want to define. So that's like two things which I know. But honestly, looking ugly is interesting. So I think that that's why I really want somebody to make extension out of it, that to define the separation, because only when we are able to write insert in the table, and it will do all this map, then we will be good. Otherwise, if you need to pull LL bitemporal insert, people wouldn't buy. No matter how cool it is, no matter how fast it is, no matter how so cool it all from. Appearance. Sorry. Okay, anything else? Did you like it?
I got something. I would suggest, put it, you know, this is the way from really fast. Maybe like in that corner, like in the execution time, because I was like, oh,
Yes, I will, yes. That is like my Sunday. Yes, I actually need to put the numbers that I missed this map, so I need to put all the numbers, I need to put the sizes, and I need to put the execution time. But yeah, then it will be very easy.
Yeah.
Okay.
All right. I have to know, let me actually turn this off because otherwise.
Thanks, Eddie. Thanks. I enjoyed the demo.
All
Thank you.
right. Okay, thank you. Thanks
Yeah,
so
bye.
much. All right, bye. All right.